Okay, guys, I'm sorry. During the class, I was recording the session, but I failed to share my screen properly. So I just checked the video and I noticed it was recorded, but my screen was not visible, so you could not see what I was doing for those who want to watch it after. So that was a mistake. So now I'm doing a repeat of the session. I'm recording myself now, and I'm going to share my screen so you can watch it later. So I'm sharing my screen now. I hope I do it well this time around. Okay. Um, okay. So I think I have shared my screen now. So we are looking at an overview of EVIEWS, the statistical software that would help us to do all this econometric stuff, estimate our data, check the graphs, look at the descriptive statistics and stuff like that. So the first thing I told you was that we can download our data from the World Bank database, and we can also download data from Yahoo Finance. So let me try the World Bank. So you just type World Bank data bank. Okay, you see the data bank. If I click on it, I don't know why I hope it opens. The network is disturbing. Okay, it has opened. So we have various databases. You come here to GDP growth, and if you click on GDP growth, the network is not the best. I just clicked on GDP growth. So you notice that we have various databases. Like if you see a database, I've selected one database, and the database that I've selected is World Development Indicators. You can see it here, World Development Indicators. That's the database I've selected, but there are many databases. Then here, country. If you click here on country, oh my God, this internet is slow. What's happening? Let me just wait for a couple of minutes. The website is slow, the internet is not the best. If I click on country, it's not going series. Oh my God. Okay, so now I've selected the database, which is the World Development Indicators. Now for country here, you can just search the name, any country. For instance, if you want to type Turkey, if I just type Turkey and I search, like press enter, you search. Its network is poor. It's not going. Oh my God. Okay, let me clear section. So I'll clear this section. Okay, I'll try again. Country. Let's search. Okay, fine. You see the list of countries. So you have the countries there you can search. Let's say Turkey. If you just search Turkey, let me search maybe Zambia, any country. Okay, you see Zambia. So you can search any country. Maybe you want to collect data for a particular country or for a particular region or anything. So now, year series, under series, we can search for the various variables. Let's say we want to collect data for economic growth or population growth or income or financial development or anything. So, economic growth is proxied by GDP, right? Gross domestic product. It's the proxy for economic growth. So if I just type GDP here and I search, so you see we have various variables. If you are just looking, you see, you go right down. Okay, you see GDP constant 2015 US dollars, GDP constant LCU. LCU stands for local currency unit, GDP current, LCU, GDP. So you select one, but it's good to select GDP constant 2015 US dollar. We always use that. It's not too good to select current values like these current values because of inflation. So it's well, when we want to use GDP as a proxy for economic growth, most often we select GDP constant 2015. If you want to get maybe income, let's say you want to get data for income, you can just search income and then you try to like scroll down. Let me see, scroll up. So you see you have adjusted net national income, adjusted net national income, you have exports of goods, gross domestic income. So you have income share, you have various kinds of variables. So under this series, you can search for your variables, and then here time, you search for the time period. Let's say if maybe you want to carry out a study from 2000 to 2021, you just come and you search, you click on all the years you want to input in your study. Or if you don't want to do that, let's say maybe you want to carry out a study for the last 50 most recent years, you just click here 50 and it automatically selects the last 50 recent years. Or if you want 25 recent years, you click. So let's take 50. So let's assume we want to download data for let's say United States of America. So I come to country, so I'll just type US, United. Okay, so you have United States. I click on it. I come now to series. Let's say I want to download data for GDP. Let's say GDP. I want to download data for GDP. You search. You come, let's say GDP, you select this one. Okay, let's say you want to download data again for maybe gross fixed formation. This gross fixed capital formation percentage of GDP, it is always used as, this variable can be used as a proxy for investments. So let's say we want to get data for gross fixed capital formation. Let's also say we want to get data for income, or let's say maybe inflation. Inflation, you just search. You see inflation, consumer prices. So this is CPI, like consumer price index, proxy for inflation. So let's select that one. And let's say we want to get data for income. Just click income and you search. So we can look for the proper one we want. Let's say we want to use, I'm just searching. Well, which one can I choose? Or let me see. Well, let's just say adjusted net national income constant 2015 US dollars. Let's just take that one. So you can get the data for various variables, and then for the time we have selected 50. So we'll include the last 50 most recent years. So once you have selected all of that, you come here, you see apply changes. You click apply changes. The data is now ready. We want to download it. If you come up here, you see download options. Take Excel. So we'll download the data in Excel form. If you click Excel, you see here the data will download. So you have downloaded your data in Excel form, right? So I'm opening the Microsoft Excel file. So if I open the Excel file, where's the Excel file? Okay, let me download again. I can't find it. Excel. What's happening? Why is it not opening? The data I downloaded, I'm trying to open it. I don't know why it's not opening. There's something wrong. Let me check under my downloads. Downloads. Still not opening. Downloads. Still not opening. I should have a problem with my Excel or something. Okay, but I've shown you how to download the data. That's how you can download data from the World Bank. I don't know why I've downloaded the data, but I can't open it. Like if you see here under downloads, this is the data that I have downloaded. But when I try to open it, it does not. It does not. It takes me to a different Excel file. It does not open. Let me try this one. It does not open. Okay, no problem. So that is how we can download data from the World Bank database, the World Development Indicators database of the World Bank. You download the data and it will come in Excel form. Now, let me show you another database where we can get data from. Yahoo Finance. We have Yahoo Finance. With Yahoo Finance, we can mostly download data for stock prices. So if I click here, the internet is trying to mess me up. Oh my God. So it's Yahoo Finance. The website does not want to open. This is bad news for me. Yahoo Finance open. Anyway, while waiting for Yahoo Finance to open, let's move ahead. Now, I already have data here which I had downloaded already. This is the data. So what you notice is finally the data I was trying to open, it finally opened. So I think there's a problem with my computer. It's slow. So this is the data I have downloaded from the World Bank database. And if you notice, we downloaded data for United States. If you can see here, United States. And the series, that is the variables that I downloaded. You have GDP, gross fixed capital formation, inflation, adjusted net national income. So and I downloaded data for the last 50 years. So you see it's from 1972 to I think 2021. So we have the data. For some of the variables, data is not available for 2021 like here. We don't have data here for 2021 and we don't have data here. So for that reason, I will take off 2021. I will just delete it. It's good to have data, the same, delete. It's good to have the same data for all the years, for all the variables. So I'm just checking we have the data for all the variables. So now, when you download data, this is how it comes on Excel. And if you come here, metadata, it's like give you the description of the data. You have the names of the variables, you have their definitions. So for instance, here, they tell you GDP at purchasers prices is the sum of gross value added by all resident producers and so on. So with the metadata, you can get the definition of the data, their sources, and it gives you extra information about the data. But we are interested in the data itself. So when you download the data, this is how it comes. You have the data in this form, in like a horizontal form. But like I told you, like I'm telling you now, and I also told you during the class, when you want to import your data from Excel to EVIEWS, you want it in vertical form, because in this form you cannot import it to EVIEWS. So we have to transpose the data. Now, let me just delete this information down here. It's not too important. So how do I transpose this data? What I will do is I'll copy the data. I can copy the data. Let's say GDP. I want to copy the data. So just copy all the data. You highlight all the data with the years. Sorry. So including their years, the time period. So I'll just highlight everything. By the way, I hope everybody can highlight it. So I'll highlight everything. How did I highlight that? Let me show you how I've done it. There are many ways of doing it, but what I do is, if I want to highlight from here to the end, I just click here, then I go right to the end, and I want to click at this last cell. But before clicking on this last cell, I will hold the shift button on my laptop. You hold the shift, and then you click here. It selects everything. After selecting everything, you copy, like Control C, copy, and then you can paste. You can paste. Let me paste it down here so we see the difference. So I'll paste it here. Let me paste it here. You click here and then you paste. You can just, normally you can paste with Control V, but since we want to transpose the data, it is not good to paste with Control V. You right click and then you come to these paste options. You look, there are various paste options. So you come to the fourth option, which is transpose, and you click on transpose. So you paste the data by transposing it. So you discover that we have transposed data. Now, what does it tell? You see that originally, the original data that we had was in horizontal form, but now we have transposed it and put it in vertical form because we want to import this data to EVIEWS. We need it in vertical form. So of course, this is the time period. This is the time period here. Then in this column, we have GDP. This is the GDP data in this column. In this column, we have the gross fixed capital formation data. Let me extend this cell. In this next column, we have inflation. In this column, we have national income. Okay, so we have our data readily available. Now, the next thing is to import this data to EVIEWS. So this is EVIEWS. I already have it installed of my laptop. So I'm just opening EVIEWS. So it is open. So you come to create a new work file. Okay, now I told you in class we have 3 types of data. Mainly we have time series data, cross-sectional data, and panel data. And time series data studies a particular subject over a period of time, maybe from 1950 to 2003 or something. Cross-sectional data studies various subjects, or you can say various cross-sections at a given time. For instance, you want to check the economic growth of all European countries in 2020. And then panel data is like a combination of time series and cross-sectional. So when you come here, work file structure, you see we have unstructured, undated, dated, regular frequency, balance panel. For dated regular frequency, we mostly use this for time series data. For unstructured, undated, we can use it for cross-sectional data, and then for balance panel, we use it for panel data. So I'm clicking dated regular frequency, and again, I'm choosing annual because the data we downloaded, if you see, the data we downloaded is annual data, that is every year for the last 50 years. Then we can also have semi-annual, quarterly, monthly, bi-monthly. So since our data is annual, I'm clicking annual. Then here I have to enter the start date and the end date. So if I come to my Excel file, you see the start date is 1972. And if I go right down, the end date is 2020. So I put that information on EVIEWS. The start date is 1972 and the end date is 2020. I'm just checking to be sure. Yes. So down here, don't bother about here for now. So once we have put in this information, you click OK. I'm closing this. So after we have done that, you click OK. The next thing we have now is a command. Now we want to input the data. So the first command we'll type is data. You type data, you give a space, and then you just list the variables. Beginning with the dependent variable, you can begin, it's good to begin with the dependent variable. So if you look at our data, we have 4 variables, I think. We have 4 variables: GDP, gross fixed capital formation, inflation, and income. So let me write up here. Maybe you can see. So what I'll write here is GDP equals gross fixed, or let's put C for constant. I told you it's good to include a constant, plus gross fixed capital formation plus inflation plus income plus U. I told you that U is the error term. So actually, this is our econometric model. This is our statistical model. So it tells us that GDP here is the dependent variable, while gross fixed capital formation, inflation, and income are the independent variables. I told you the independent variables, we can also call them the regressors, while the dependent variable, we can also call it the regressand or the explained variable. The independent variables can also be called the regressors or the explanatory variables. So this C here stands for the intercept or the constant, while this U is the error term. And I told you that this error term accounts for all other factors which can affect this GDP, but which we have not included in the model, because this GDP will not depend only on gross fixed capital formation, inflation, and income. There are other factors that will definitely affect this GDP, but we cannot include all of them in the model. So this U error term represents those other factors which will affect GDP, but which we cannot include in the model. Okay, so now that we have this econometric model, now we want to input this data from Excel to EVIEWS. So our variables are GDP, GFCF, INF, and INC, and you know what they stand for. So I'm going to EVIEWS. In the command bar, I type data, I type GDP. After GDP, what's the next variable? Gross fixed capital formation. Then we have inflation, and we have income. So you type just the variables. You don't type the constant, you don't include the error term, you just include the variables. And once you finish writing the last variable, you press enter. Okay, so after doing that, you notice we have the worksheet. An empty worksheet has been created on EVIEWS for us to paste our data. So I just go to Excel and copy the data. Copy only the data. You don't copy the years or the titles. You copy just the data. And like I told you, there are various ways of copying it, but the way I do it is I just come here to the first cell, I click, then I scroll to the last cell down, and I want to click on this last cell, but before clicking on the last cell, I hold shift and then I click. So you see it highlights all the data. Then you can copy Control C, and then you come to EVIEWS. When you come to EVIEWS, you come to the very first cell here and you paste Control V. You paste the data. So you discover that we have copied the data from Excel and pasted it in EVIEWS. After doing that, we can close it. Delete untitled group, yes. We have the data there, so you see GDP, gross fixed capital formation, income, inflation. Our data is there readily available. Now that we have imported the data to EVIEWS, we can now work with the data on EVIEWS. So there are many things we can do. First of all, let's look at the graphs of the data. So I'm selecting the data. GDP is always good to start selecting your dependent variable first. So I want to select, you can do it one after the other. For instance, if I select GDP and then you press enter, you see this is the data for the GDP. This is the GDP data from 1972 to 2020. If you come to view, you can check graph. You see a basic type, don't touch anything for now. Line symbol, let's use line symbol. So don't touch anything, just click OK. So that's the GDP graph. So we can check the graphs of each of the variables one after the other. Close it. If you want to check gross fixed capital formation, you click on it, you press enter, you come to view, you go to graph, and you don't change anything, you just click OK. We have the graph of gross fixed capital formation. So we can check the graphs of each of the variables individually. Also, we can check the graphs, all of them at once, which is good, and it helps us to see the graphs of all the variables, and we can explain the graphs. So if you want to check the graphs of all the variables at once, we have to select all the variables. So I'll select GDP, my dependent variable first, then I'll hold Control key, and then I'll select all the other variables. Now that I've selected all 4 variables, I can just press enter on my keyboard, and you see the data of all the variables opens at once. So if I click on view, I come to graph. I'm just changing here from single graph to multiple graphs because I want to see all the graphs at once. So you see all the 4 graphs of all the 4 variables opens at once. And it's good to look at all the graphs at once because it's easy to explain. Now, how can we explain the graphs? Like I told you in class, when you want to explain the graphs, you have to be mindful of what the dependent variable is. Remember, our dependent variable is GDP, and then gross fixed capital formation, income, inflation are our independent variables, or you call them the regress. So now, look at the dependent variable GDP. You discover how the graph is going up. Now, let's start interpreting the first graph, gross fixed capital formation, or since there are fluctuations, let's look at this income first. Look at the income graph. You discover that income graph is going up, and then you see GDP graph is also going up. What does it tell you? It tells you that there is a positive relationship between GDP and income, because both graphs are going in the same direction. But when interpreting it, you don't say as GDP is going up, income is also going up. That is wrong. Why? Because GDP is our dependent variable, so GDP should react to what is happening to income. The dependent variable should react to what is happening to the independent variable. So instead of saying that as GDP is going up, income is going up, what we instead say is that as income is going up, GDP is going up. So the dependent variable should react to what is happening to the independent variable. You understand? And I told you that it's always good to use the word on average, because it is not in all cases that it goes up. Like for instance, here in this income graph, you notice that somewhere around here, it like comes down and then goes up. But on average, it is going up. So what you will see is that on average, as income goes up, GDP also goes up on average. Therefore, from the graphs, we expect a positive relationship between GDP and income, right? Because if they are going in the same direction, it is positive relationship. But if one is going up and the other one is going down, then it is negative relationship. So if you look at this gross fixed capital formation and this inflation graph, there are lots of fluctuations. So it is difficult to call. It is difficult to explain this kind of graphs, because you don't really know what to expect. It's going up and coming down, going up and coming down, lots of fluctuations. But at least with the income graph, it is easy to explain, since it is going up and then GDP is also going up. So that is how we can explain the graphs. Now I'm closing the graphs. Close. The four variables are still highlighted. The next thing I want to check is the descriptive statistics. So I can just press enter, and then I come to view. I come to descriptive statistics. We can look at individual samples, common sample, but it's good to always look at common sample, because if there are some missing variables, it tries to like synchronize everything, and it makes our life easier. So I'll check common sample. Now we have, for all four variables, we have the mean, the median, the maximum, the minimum, and stuff like that. So obviously you know the mean is the average value, the median is like the middle value. When you arrange all the values from in ascending or in descending order, the middle value is like the median, the maximum is like the highest value, the minimum is like the lowest value, and then the standard deviation shows you like the variability of the data, shows you how the data deviates away from mean value, from the average value. Then with skewness, kurtosis, and Jagbera, we use it to check like the distribution of the data, to check if the data is normally distributed or not. Skewness and kurtosis can give us an idea, but the Jagbera statistic is what we use to actually perform the test for normality. For instance, for normally distributed data, the kurtosis value is like 3. Normally distributed data has kurtosis of 3. So if it is more than 3, then it is not normally distributed. If it is less than 3, it is not normally distributed. But if it is 3 or around 3, then we can say it is normally distributed. So kurtosis and skewness gives us an idea about it. But the Jagbera test statistic is used to actually perform the test, so that we should be sure if it is normally distributed or not. And to carry out this Jagbera test, we have the null hypothesis and the alternative hypothesis. Let me open Microsoft Word so I can write something. So with the normality test with a Jagbera test. So we use the Jagbera test statistic to, at times this Jagbera can be abbreviated as JB. So we use it to test if the data is normally distributed or not. And we have the null hypothesis, which we can represent as H0. And we also have the alternative hypothesis, which we can represent as H1. Now, for the Jagbera test, the null hypothesis says that the data is normally distributed. The alternative hypothesis says is the opposite. The data is not normally distributed. So now what we do is we have three levels. We call them significance levels, or you can call them alpha. We have three significance levels. We have 1% level of significance, we have 5% level of significance, and we have 10% level of significance. So what happens is that with the Jagbera test, I'm going back to the results on EVIEWS. We don't bother too much about these Jagbera values and the test statistics, because just by looking at these probability values, we can perform the test. So we focus on these probability values. Now, these probability values, at times they will call them P values or prob values. They are the same thing, they're actually probability values. So we are interested in if these values are less than these our significant levels or not. If the probability value is less than 1%, then we say it is significant at 1% level of significance. If it is less than 5%, then we say it is significant at 5% level of significance. If it is less than 10%, then we say it is significant at 10% level of significance. Okay, what you notice is that if it is significant at 1%, then therefore it is also significant at 5% and significant at 10%. But it can be significant at 5% without being significant at 1%. If it is significant at 5%, then therefore it is also significant at 10%. Again, it can be significant at 10%, but without being significant at 1% and not significant at 5%. If it is greater than 10%, then it means it is not significant. It is insignificant, even at 10% level. So we want it to be less than. Are we there? Okay, what happens is that we are concentrating on this hypothesis, the null hypothesis and the alternative hypothesis. If our probability value is less than the alpha or the significance level, which means it is significant, then we can reject the null hypothesis. If we reject the null, then we accept the alternative. Let me write something here. If we reject the null hypothesis, then we accept the alternative hypothesis. we never accept the null hypothesis. Is either we reject the null or we not, or let's say, or we are unable to reject the null. Very important. So it is either we are rejecting the null or we are not able to reject the null. Sorry. It is because I'm saying so because somebody might think that if we cannot reject the null, then we accept the null. No. I've written here, we never accept the null. So you never say that we are accepting the null. If you ever hear the word accept, the only thing we can accept is the alternative. We can only accept the alternative. And the only time we are accepting the alternative is if we are rejecting the null. So if we reject the null hypothesis, then we accept the alternative hypothesis. But which means that the only time that we even look at the alternative hypothesis is if we have rejected the null. So if we reject the null, then we accept the alternative. But if we cannot reject the null, then we don't even bother about the alternative. And you don't say we are accepting the null. What you say is that we are unable to reject the null, or you say we cannot reject the null. Again, I'm insisting, we never accept the null. Okay. Now, when do we reject the null or we cannot reject the null? We can look at the probability values, the p-values. If the probability value is less than the significance level, then it means that it is statistically significant. Therefore, we are rejecting the null. And if we are rejecting the null, it means we are going to accept the alternative. But if the probability value is greater than or even equal to the significance level, then we cannot reject the null. We don't say we are accepting the null. We say we cannot reject the null, which means we are not even interested in the alternative. So that is how we carry out the Jagbera test for normality, to test if the data is normally distributed or not. So I'm going back to EVIEWS. If you check this probability value, it is 0.13, which is 13%, and 13% is greater than 10%, which is greater than 10%, which means even at 10% level of significance, we are not able to reject the null. That is how we explain it, we analyze it. Since the probability value is greater than 10%, remember I told you, in order for you to reject the null, the probability value has to be less than the significance level. So since our probability value here is 13%, which is greater than 10%, therefore it is not significant, so we cannot reject the null. And what is the null? The null says the data is normally distributed. If we cannot reject the fact that the data is normally distributed, therefore we conclude that our data is normally distributed. So for the first variable, GDP, we have performed the test and we have concluded that the data is normally distributed. The same thing with gross fixed capital formation. You see here is 74% and income is 13%. So for this gross fixed capital formation and income, the probability values are also greater than 10%, which means it is insignificant. We cannot reject the null. Therefore, we conclude that the data is normally distributed. But in the case of inflation, the inflation variable, You look at the probability variable, the probability value rather 0.00, which is 0%. It is less than 1%. So you see that the probability value there is less than 1%. It is less than 1%, which means, how do we interpret it? So we say at 1% level of significance, we are rejecting the null hypothesis that the data is normally distributed, and we are accepting the alternative hypothesis that the data is not normally distributed. Because I told you that if you reject the null, then you have to accept the alternative. So since our probability value is less than 1%, it means that at 1% level of significance, we are going to reject this null hypothesis, and so we will accept the alternative. Therefore, the data is not normally distributed for the inflation variable. That is how we carry out the normality test to check if the data is normally distributed or not. So with the other items of the descriptive statistics, we have observations, just to tell you that we have 49 years of observations. We have the sum, like you sum up all the variables. That is it. So that is that about descriptive statistics. I'm closing it. Okay, now what I want to show you is the logarithmic form of the data. So this is level data or the raw data, because it is the data that we just downloaded from World Bank in Excel form, and we've imported it to EVIEWS, and we used it without transforming the data. So that is the raw data or level data. But most of the times, we use the log form of the data, that is the logarithmic form of the data. And there are many reasons or advantages for using the log, which I will also explain. But first of all, let's generate the log form of the data. So how do we generate the log form? You type GNRO, which is like a command which stands for like generate. So I will say like lin GDP equals log GDP. What does it mean? It means I'm telling EVIEWS that EVIEWS should generate a variable called lin GDP, which is actually the logarithm of GDP. So if you press enter, you see it here. This is the variable down here. You see the variable has been generated. I go back to the command bar. I want to generate the logarithmic form of all the variables. So the next one is gross fixed capital. So GN generate lin gross fixed capital formation equal log G. So you press enter. So you can do it one after the other for all the variables, but in order to save time, you can just do the first one and then you can just keep editing it. So if I want to generate the log form of inflation, I just come here and I just edit to INF. I also come here, INF. Then I press enter. They say log of non-positive number missing data. I will take OK. It's because you cannot generate a log of a number which is not positive. So since we have some negative numbers in the series, we will have some missing data. There is a way we can do it, but for now, let's just take OK. So we'll do that of income. So I'll just come here. I'll type INC, and then I'll type INC, and I press OK. So you discover that I have generated the logarithmic form of the variables. Now, like I said, there are advantages, there are reasons why we want to use the logarithmic form in doing our research, in doing our analysis, and in doing our studies. Why? First of all, by taking the log, it rescales the data and it reduces the variability in the data. So if the variance of the data is not constant, we call it like heteroscedasticity. We'll see it. I think maybe in this course we'll see it, but they call it heteroscedasticity. Like if the variance of the data is not constant, that is the residuals is not constant. So by taking the log form, it tries to solve this problem, and at times it can solve this problem. So it rescales the data and reduces the variability of the data. Let me show you. For instance, let's take GDP data, and let's also take lean GDP. So I've selected both of them. Remember, you select the first one, you hold control, you select the second one. I open both of them. Okay, let me just look at let's wait, let me just check something. Let me look at gross fixed capital formation. Okay, let's take gross fixed capital formation and let's take its logarithmic form. Sorry, gross fixed capital formation and its logarithmic form. I open both of them together. So let's look at the graphs, for instance, graph of both of them. I'll take multiple graphs so I can see both graphs together. Okay, you notice something. Look at the first graph up, gross fixed capital formation. You see it ranges from 26 to 16. So the range is like, there's a range of 10 from 16 to 26. But when you take the log form, you see that the range is from maybe 2.8 to 3.3, which is a smaller range. So you discover that when you take the log form, it rescales the data and it reduces the variability, which is good. It does not really change much. If you look at the graphs, both graphs are very similar. So by taking the log form, it does not really change much in terms of like if you see the graphs are the same, similar, but at least it rescales the data and tries to reduce the variability in the data. And if there are problems with the data, for instance, if the data is not normally distributed, it can help the data to become normally distributed. If there is heteroscedasticity in the data, that is, if the variance of the errors are not constant, it can help to make them to become constant. So you see that by taking the log form, it tries to solve some problems that we can have in the data. That's the first advantage of taking the log form. The second reason why we might want to take the log form is it helps us to easily analyze our data because we can express everything in percentages. But if we are using the level form, then in trying to analyze our data, we need to be using the units of each variables, which variables have different units. But if we take the log form, then we can express all of them in the same units. We can talk of percentages. So there are some advantages of using the log form of the data. So that is how we can get the log form. Now, we can also get the first difference. We can also get the lag form of the data, which should I show you? Or let me see. Okay, I think that should be enough for now. Maybe you just watch this video, try to understand it, and if there is anything you don't understand, you can ask me. You can send me a message on Teams, or you can come to the office, BE 160. Next class, we'll talk more on other things on EVIEWS. I'm sure next class, tomorrow you have your first lectures with Nigaoja. So when whatever she tells you, she'll tell me, and I'll come again and we'll still see some interesting stuff on EVIEWS. So I've showed you how to download data from WebBank in Excel form. You import it to EVIEWS, and there are things you can do with the data. What I'm also going to show you is how to download data from Yahoo Finance. I tried it, but my network, okay, I think it's open now. So we have Yahoo Finance. How did we get to Yahoo Finance? We just come to your search button engine, you just type Yahoo Finance and you just click here. You can download data about stock prices. So if you click there, it will open like this. So let's say we want to search any company. Let's say Apple, the company which produces iPhones. So we can search Apple. See, my network is stable. It's taking time to load. Oh my God, what's happening? Let me search Apple company, Apple Incorporation. It's one of the big 5 technology firms in the US. It's actually, the last time I checked, it is actually the largest, the most valuable company in the world in terms of market capitalization. I'm not so sure about that today, but that was last time I checked. I'm trying to check. Let me check again. Okay, let's check Facebook. Let's check Meta. You know, Facebook recently changed its name to Meta. So you see Meta. So I'll click on Meta. I just want to show you how to download data from Yahoo Finance. You can download price data. So this is Facebook, that is a Meta company. And we can have various information. Let's come to historical data. Click on historical data. Okay, actually this is the current stock price of Facebook's stock, but that's not our interest for today. I just want to show you how to download data. So if you see here, you have dates, open, high, low, close, adjusted close. So today or yesterday was October 10th. Open, like this 133.5 was the opening price, like the stock price of Facebook stock. This was the opening price yesterday. This was the highest price yesterday throughout the day. This was the lowest price. This was the closing price. And this was the adjusted closing price. And this was the trading volume. Most of these things you will see them in investments, FINA 503. So if I want to download data, let's say I want to download stock price data, you come here, time periods, you click. So you choose the date. So I can say I want to download data from, let's say, from 5th October to 10th October. I click done. So I fix the date. Now, historical prices, let's leave it at historical prices. Okay, let's say you want to download daily data. The data for every day. You can also download weekly, monthly data. So let's leave daily data. You apply. You click apply to make sure that everything you have selected is fine. Okay, it has been applied. So you see what's happening. The time period changed. I'm going to change it again. Start date should be let's say 8 October, and then end date 11 October. Apply. I don't know what's happening to the network. The network is too slow. It's not going. Oh my God. So once you have selected the period and you will want daily data. Normally you click here download, and you are going to get the data. You see it is downloaded down here, and it will be downloaded again in Excel form. So if I open Microsoft Excel, if I open the Excel file, you see we have the data there. So that is the data in Excel form, and we already have it in vertical form. So if we want to import to EVIEWS, it's easy, unlike with the web bank where we downloaded the data in horizontal form. So that is just how we can download data from Yahoo Finance. I've also showed you how to download it from web bank data bank. So that is it. Okay, I will just show you one final thing on EVIEWS before I close the session. I want to show you like the correlation metrics. So what I can do is, let's use the log form of the data. So I'll take lin GDP. It's good to always start with your dependent variable. I'll hold control. I'll select the other variables. I press enter. I come to view. I come to let's see, covariance analysis. Oh no, not covariance analysis, sorry. I'm looking for it. Or I think we should open it one after the other. Delete. Open as a group. Okay, covariance analysis. I would like uncheck covariance, and then I will check correlation. So that is the correlation metrics. I'm going to repeat the process again. So you select all the data, you press enter, you come to view, you come to covariance analysis, you click. We want to look at correlation metrics. So I will remove covariance and tick correlation. Then I click enter. So this is our correlation metrics. Now, if you look at this correlation metrics, you see here you have GDP, gross fixed capital formation, income, inflation, GDP, gross fixed capital formation, income, inflation. So this correlation matrix shows you the correlation between the variables. Like it shows you the linear relationship between the variables. Now, if the correlation, all these values we have here, we call them correlation coefficients. If the correlation coefficient is higher than 70%, then we can say there is a strong correlation. If it is between 30% and 70%, then we can say there is medium correlation. If it is less than 30%, then we can say there is weak correlation. This correlation can be positive and it can also be negative. For instance, you see here minus 0.4, that's negative correlation. Here 0.9, positive correlation. Here minus 0.48, that's 48%. So it is medium correlation. Here 0.99, that's 99%. So it is strong correlation. Here, well, I cannot find any weak correlation because there is no less than 30. But again, if it is above 70%, we can say strong correlation. If it is less than 30%, weak correlation. If it is like between 30 and 70%, then we can say medium correlation. So it shows like the linear relationship between the variables. So for instance, this 99 here shows you that GDP and income have a very strong linear relationship, which is also positive relationship. This 1 year 48% shows you that GDP and gross fixed capital formation have a medium linear relationship, medium correlation, and it is a negative relationship, you see. So that's how we can explain the correlation metrics, the correlation coefficients, and I've showed you how to get it. So I think that is enough for today. Subsequently, in other sessions, we'll be looking at other things. Okay, so I'm closing everything. Save no. I'll just delete everything. Okay, so I should stop recording now, so the video is not too long. What have I done? Okay, see you. Bye bye.